We're connected. Okay, so let me turn off the thing that I've got stopping the robot. Okay, now the robot's going to try to track down, same thing, it's finding a path on the objects, on blobs, and it's going to try to drive down that path. We've got it set at a really low speed because we didn't want it to go off the table, but it sees objects and then it'll turn away from them and try to go down a path.
So it's capable of going faster?
Oh yeah, much faster. Put those cups a little closer together because right now it sees a path down there and it's wanting to go down that path. But the light, right now this lighting is kind of weird. It definitely likes bright lights, but that's because we're using a cheap camera and a small Christmas tree ornament. If we took off the Christmas tree ornament and just pointed the camera forward, it wouldn't have as much side vision or back vision or 360, but it would be a lot better at seeing objects because they'll be larger and driving in the path. Let me show you real quick what the blob looks like. Let's see if I can get one. Master flood fill marker. I think this is blob. It's not making them colorful, but it's turning them black. I can make them look colorful. Somewhere. Maybe not there. No. But I'll show you quickly what it would look like. Let me kill the robot real quick. I'm killing the robot again. Okay, blob, object, avoidance. This is the robot view if it was just a pointed camera forward, like different color objects. Then edge fill, like you saw that shot where it was doing the candy and then it just rounds it off. So we just followed the same everything.
So basically what happens is in that image, once you go back.
Alright.
Basically what it does is it takes a particular color, whatever is the most in that image, and assumes that that is the floor. And it marks that image and it whites it out so that it knows in which direction to go. So it just assumes that that's a path for it to go. If there's things on the side, it's gonna darken them out. So that way that's how it defines its set course.
Right. For blob tracking, let me move just a second, Adam. It does the same thing. It looks for objects that aren't the main object on there, and it labels those as blobs, and then it does the same thing where it just filters it out and finds a path and goes down there. The problem being that if you had a floor like this, it would have lots of issues and it wouldn't be able to find a path because these all would be little blobs, and you can filter them out. But
you can try to filter as much as you can out, but sometimes the more noise in your image, obviously, the less resolution you're going to have for your data.
Alright, so the blob sees a lot of little blobs and the edge sees a lot of little edges, so it wouldn't be able to find a path through this picture. So the third one that we used is called floor following. So if you want to turn on the robot, and we'll just quickly show you. They all kind of look the same, but they do different things. So you want to be able to switch between them based on how the robot's performing. And you can put them all in one robo file, like I said, and switch from them quite easily.
You can pipeline the robot to react in a certain manner. If it's, let's say, if there's something in front of it, then it will jump to that code where it's going to avoid it. Or if it notices a red object, then at that point you could say, okay, now you have to go and follow that object.
Let me disable the saber tooth and we'll try again. Alright, go ahead. Oops, dim already.
No, it's not working.
No, didn't do it.
Give it like 5 seconds and then
okay. Go ahead and power it on.
If you just disable it, you can switch them over.
I know, but I want to stop and start. There we go.
It's connected.
Okay. Let me move the thing that has it stopped. And then it should start taking off. So right now it doesn't see any objects. And what's going on is there's this little triangle here, and that's our sample of the floor. So it says, okay, anything that looks like this is floor. And so right now there's shade, or I guess there's a shadow or something's not looking right, but it's probably going to stop at the edge because it doesn't look like the floor. So it doesn't look back. So it's kind of iffy. But, yeah.
So basically, this would be a
going to like for the future autonomous vehicle algorithm, correct?
Right, you can use that in that application.
So it looks about the same, and I'll close that. If you want to put objects in front of it, you can, just to show them that it sees those as objects.
Hey Adam, could this be applied to your humanoid robot?
Yes.
That's kind of what we wanted a little test sample.
I have on the YouTube video where I've applied that, where I put a soccer ball in front of the robot, and the robot has to react to it, and basically what it does is it'll follow the ball and then set it up to where it can kick the ball. And I'll go ahead and show that.
Alright, well I'm going to go to the interesting stuff in just a second. But Floor Finder, I'll just show you real quick what it does. It's going to see what the floor looks like, and then it finds blob, and then it does the same thing. It does the fill, and decides everything above it is a block, and so then it finds the path. The same thing. And that was object avoidance. For the Pi robot, when he was doing object avoidance, he does a little bit differently. That's what he looks like. He's done the same thing where he's unwrapped the Omni ball. Then he does a different type of Pruitt edge filter, so it looks like this image. He does a few more filters, and then I'll show you some videos real quick so you can watch what's going on. So he gets a much better view. He's doing, instead of one point, he's doing a whole bunch of points, and then he calculates where the best path is based on how many points he sees, and the density of them. And they look like that on the screen. And he's really good for, like with an ultrasonic sensor and things, wherever you're pointing it, you might not be able to pick up small objects because it wouldn't really bounce off of them well. And it might not be able to do like cables or chairs or things where the robot can get under them and get stuck. If you hit the lights, you'll be able to see this a little bit better. But in this case, it finds like chair legs and things like that the ultrasonic sensor might not pick up because of where they're located in the view. This is a quick video, I might not show all of it, of his robot actually running around objects. So this is the old robot, and it just drives around and it picks up like chairs. If anybody's had a robot that runs into things, this is a pretty good way of not doing that. So that's pretty much what it's doing, is it's finding stuff. Yeah, there goes
the cool thing is like he was talking before about security robots, you could have this robot in an environment where you pre-program it and it would just basically roam the environment. Or you can set up a predetermined path also.
Right. Here's the fun part where you can actually see what the robot sees. And he's got a lot of filters on it and it's doing a lot of edge detection. This is what the robot sees in its world. It's pretty cool, all these edges and things. I haven't been able to get mine to look anything like that, but if I did, I'd be really happy. So.
There's probably a setting for what the skew is on contrast detection, and you've got it set too low. It's set it higher so that it looks for a sharper edge, and the rest of the filters will fall in line.
Right.
See if you can find that.
Yeah.
I think it also has to do with the amount of light that we've been working with pretty low light environment.
When you said red detection, how do you set that? Do you
it's in the module. You can set
I'll show you that real quick.
But does it give a range for red?
I'll
Because
show you.
red varies based on what
Right.
I haven't developed the code that far yet. I wouldn't know. It's possible.
You can
You
have
can
change.
change the intensity of the...
So we chose red, and then you do like, if I go like this, it'll get rid of a bunch of them, or if I go like this, it's going to pick up a bunch more. And the light right now is
you can get different hues as well. You can double click both of those, and you can take both. Like if you click red and green, then it'll...
Oh yeah. So I can add extra colors to the map, so that'd be how you do everything, where it detects everything based on different
And the cool
colors.
thing is you can see what the robot is seeing in real time, so then you can kind of figure out where you need to be as far as your code.
Yeah, that's a critical setting right there, the threshold.
Yeah. And you can change all that, like I'd be able to change it all from the web page if I had a slider or something, which I like sliders, but you can do checkboxes and things to see what the robot sees and then adjust accordingly. So, and then like I said, he does a bunch of points, and he just puts the points on the screen and calculates based on where the points are, how the robot should move, or what path it should try to track down and go for. So, and he's using a 360 view as well, so everything's kind of skewed and looks kind of like that, but it's so the robot can find a really good path. So things come closer really quick. So, that's it for object avoidance that we found. Using Robo-Realms, but I mean, you can pick your own and do whatever you want it to do.
Pretty good.
Yeah.
Good job.
he's got instructions and he shows his hardware and stuff like that for that. That's the old Pi Robot. The new Pi Robot is, I'll show you real quick.